So can I start by first going to each of you? Joachim, we've already met you, but let's start with you again, just to introduce who you are and why you're in the discussion on hydrogen in this meeting.
Yes. So I work for a company called Linde that is the world's largest industrial gases company. And we are very much involved in a clean energy agenda. I work particularly myself with the hard-to-abate industries across the world. We have a long history in this. When talking about hydrogen, it's more than 50 years, I would say. So we are all across the value chain, and we have sales at about 3 billion in hydrogen. We operate a lot of electrolyzers and SMRs, in total about 250 of those. We operate 100 kilometers of pipelines. We have huge caverns. We have liquefaction capacity and all that kind of things. Big fleet of tankers. So we've been around with these kind of things, and we're also developing technologies for many other things like low carbon fuels, CCS. We work together with different partners in big projects, and a lot of energy efficiency and so we're really all over that space, and a lot of these are in my toolbox, so to speak, when I work with our customers in those heavier industries and so on, where I have my background and my team is there all over it. So we have a big and important position today, and I think that based on that and the experiences that we have gained, I think that we can have a bright future going forward with this, and work together with different customers, in different constellations, governments, etc. And with an example, as I mentioned in the previous discussion, with the project with the OCI in Texas, where we are then will be the supplier of the blue ammonia, we can then find pieces where we are the best one, hopefully, and piece that together with other partners in these large projects. And in these, the business models that we have applied through more than a century can work very well, where we create these clusters, valleys, and so on, and work out from that. And we know what are the ways to do these kind of things, and what are the risks, and so on. Thank you.
Samantha, would you like to go next?
So thank you very much. Can you hear me? Yeah?
Yes.
Good. So I work for Fluor. I've worked at Fluor for nearly 30 years. So Fluor's a global company. We're a global solutions provider. So we work in urban solutions, energy solutions. We have a vast amount of projects that we're working on, from the giga projects, $50 billion US dollars, to the very small projects. I'm going to talk about it a bit later, hopefully. So we're helping universities with pilot plant, that kind of level, bench scale. So we've got so our first hydrogen in a refinery project was 1968. We feel we're experienced in hydrogen. We know about it. And we've been doing carbon capture and storage carbon capture, we've had the ability for about 30 years. We've got various plants across the world with our economy and FG Plus for post-combustion carbon capture. We've also got pre-combustion carbon capture, which is Fluor solvent, propylene carbonate. But overall, we see ourselves as key for partnering or collaborating in the energy transition. We're working on a number of energy transition projects, from direct air capture, carbon capture. So project I'm working on at the moment is wood chip to sustainable aviation fuel, ammonia cracking, ammonia production. The list goes on. Talk to me talk to me later if you need a wider list. But we feel it's very important to collaborate. I don't think there's one answer for everything, and I think we need to work with industry, with government, with small companies, with big companies, with Linde maybe.
Most welcome.
To work together towards the future.
Thank you. And Thomas.
Well, good afternoon. Just about. I work for KPMG. It's a very big company. We're not audit or tax or legal. We are in the deal advisory space. So our work, of course, is wrapped in confidentiality. So I can't go into too many sort of specifics. But effectively, our work is split between two branches. The first one is to work with large established firms, whether that's a oil and gas major, a utility company, a power generator, basically someone who manages assets, take that portfolio and then develop a decarbonisation strategy around that portfolio, identify the technologies, the partners, the business model, the financing, etc., all of the M&A activity required to go and deliver it, and then work with them to then decarbonise their portfolio. And then on the other side is to work with the small guys and then bring them into the market. So this is principally looking at technology providers. So someone who has invented a very clever widget, and then how do you take that widget from lab scale through to pilot, through to mass production, and all of the business functions that sit around that technology that actually bring it into the market. My background is in engineering, where I worked actually for Chris for 5.5 years, and prior to that, Exxon.
Thank you. Thank you. Good. Already we've been discussing hydrogen all morning, actually, and here we have a session that's now focused on hydrogen, which I think is very, very and thinking about some of the challenges we have in hydrogen. I'd like to just touch on safety. It's been mentioned, but is it something that we need to think about from the design? Who wants to take on that one?
Hydrogen is not a new thing. So we've done it for decades, right? We need to understand hydrogen in a larger context, I think, because we basically used to supply it for heat treaters, and then of course a lot of hydrogen was used in the chemical industry only. That's still the vast majority, and those people know it pretty well. If we go beyond that, we got to understand. I think that there's some observations. One is that hydrogen is in general a little bit less useful than people think, but it's also less dangerous than what people think. But if we're going to transfer hydrogen, we have to remember that if we use it as a fuel, compared to natural gas to make them, we need 3 times more, right? So we need to push that. If we will push that through the same pipeline, we need to increase the pressure, and we have these small molecules that has a tendency to sneak out. And then we have to be very careful with the welds and so on. So when we increase the pressure, they have easier to sneak out. Normally, they go straight up to the sky, but they're very good at ignite. So we need to be careful with that, and I don't think that we should have a general distribution of hydrogen. We should use it probably mainly where we produce it. But again, we know how to handle these things.
So, so industrially, we're really used to handling hydrogen, but perhaps not so much the general public. So I think there's an example where in a fueling station in Norway, there was an explosion that it was it blew up, and nobody was killed, but it's a warning that the car alarms and it affected hundreds of meters around. So we have to understand that the general public aren't trained in hydrogen, and also big companies have been handling hydrogen for a long time. We have got the experience, and we do have the know-how, and we're working. So Fluor, for instance, are working with the HSE to try and improve the situation where maybe people that are less experienced are suddenly becoming hydrogen experts, And all these some of the electrolyser companies are maybe not as experienced as they need to be, and there cannot be a case where a hydrogen causes multiple deaths. We can't learn from the experiences that we did from the oil and gas industry, where numbers of people died coming to where we are. We need to have it needs to be right first time, and also confidence that the public will be destroyed. It's happened in Norway. Green hydrogen is no longer anywhere near as popular in Norway because of this explosion. So we've got to learn. But
I think what I'd add to that is that safety is quite clearly a prerequisite for deployment. It isn't really up for discussion as to how safe you want it. Then it's a prerequisite. And yet, as Samantha said, it is the fastest way to lose public support, is to have a big incident that then puts off policymakers, puts off funding, and the whole industry comes down. So it is fundamental to deployment. I would add that here in the UK we have a very well established and very mature safety framework. So it starts with the Health and Safety Work Act, and then down to the secondary legislation that follows. And then we have a duty holder philosophy where you are, as a duty holder, responsible for your hazards, irrespective of whether you understand them or not. So there is an onus on duty holders to understand and to manage and control them to an acceptable level, and that's a very well tried and tested framework. So I suppose I'm saying I have confidence that our current legislation and general safety appetite in the UK is one which will manage this transition in a safe way.
The predominant use, and probably even it will not go beyond that, is in the industry. I'm not so sure that we will see much of use of hydrogen in the general public. There are discussions about using it for cooking and things like that. I think it's quite aspirational, to be honest. And when it comes to personal cars, it's very limited. Heavy duty trucks, potentially. I mentioned some examples with ferry boats and trains. Yes, but that's more of an industrial type of an environment where people are used to it. And this is where we start anyway. And we have the safety standards, and we will hopefully learn from that they are in place before we go further in a number of decades in that case.
Thank you. We've touched on this discussion, but again earlier on in this morning, you sort of inferred that there were places where hydrogen can be a major role, but there's things that whether it's electrification or whether it's hydrogen, what's the best way forward?
Oh, electrification.
And hydrogen is a derivative of electrification.
Well, when I deal with these big steel companies, etc., of course we try to apply they try to apply electrification wherever that works. But there are, for a number of things, for reduction, it's better to use hydrogen. And then if you look at it as a fuel, there are enormously large furnaces and so on, and you need to use combustion, and you cannot today apply electricity there. So fine. But you have to first check, can you use the electricity directly somehow? That's by far the most efficient. But there are limitations inside, there are high temperatures and so on. But I think we need to program ourselves to not look for hydrogen in the first instance, but look for how to use the electricity first.
You're both nodding.
Well, yeah, you go.
Oh, thank you. I think I see a slightly different view. So I tend to not engage too much in crystal ball gazing around end uses, because I draw a parallel to say the 1800s, when we were developing the first electricity grids. And imagine going back then and trying to determine, well, where's the best use of electricity, and where we're going to restrict electricity, and where can we only use electricity. I think prediction based on technological development is something which is very difficult to do, because your reference point is always what's my current constraints. And And as we've seen, over the last 100 years, technology evolves far beyond the imagination of the present day. So I think it's a more helpful framing, I think, is to ensure that we have the right policy frameworks and market frameworks to then allow the combination of market forces and consumer free will to then determine where things are used, and not try and design the market from day one and restrict use cases where there may be a perfectly valid use.
I was just really going to agree with Joachim that you have to look at electrification first, but it's not applicable in all areas. And heavy transport is one area which it doesn't make sense to use batteries really at the moment, unless something dramatic happens with battery technology. So we have to go for electrification, but also our national grid is being upgraded, but it's not sufficient for us all to have electric cars at the moment. So it's an onward going process, but electrification first, I think.
Thank you. Hydrogen and hydrogen economy, but we also have hydrogen derivatives. Do you want to think through from a perspective? There's ammonia, and I take what you've just said. So, but thinking through ammonia, methanol, etc., and the need for hydrogen carriers. Can you bring that into the discussion?
I think the transport of hydrogen is very difficult. I think Scheele have got their ship that transports hydrogen from Australia to Japan, and they've been testing that for a long time to make sure it's safe. I know that Maersk are now concentrating on methanol for their shipping. We're working on an ammonia cracker for releasing hydrogen. So there are a number of ways of transporting hydrogen, but maybe we should be thinking of producing hydrogen locally to where we need it, and Heine is a brilliant example of that from my...
I think we need to be careful with thinking that we can transport hydrogen longer distances, and that might also go for ammonia. Then it's not very energy efficient way to do it, and if it was green at the starting point, it might not be that green at the end. What might happen is that we will have a dislocation of certain value chains, and the production of certain products will take place where we can have the clean energy supply at the affordable cost, and we produce those products there. We could be semi-finished products, and we transport them instead. So in the steel sector, for example, I talked to a lot of plants where we talk about making direct reduced iron and turn that into a briquetted thing called HBI, and transport that from Australia to Europe, from Brazil to Europe, from Africa, different countries, Namibia for example, to Europe, instead of transporting the hydrogen or the ammonia to Europe and produce those products. That is part of the steel production value chain. And we could even produce, in that case, semi-finished steels, move that to Europe and do the rolling and so on. I think that we might see these kind of things happening, which is a little bit of a threat. But that is the situation where we're not having a viable supply of clean green electrons today here. So I think it is much more efficient to transport these products than to transport ammonia or hydrogen. And I think the industry have understood that. We see that from the projects.
I think the question of carriers is slightly second order, because it's a function of the interaction of two markets. So if you can produce hydrogen domestically and use it domestically, that should be the first port of call. A carrier comes into play when that's not an option, and then a other supply market is now your source, and it's being moved from A to B. So the question of what is the best carrier, what's the right carrier, if you can use that terminology, is something which I don't think we're at a position to be able to forecast with any great degree of certainty, because it's based on two independent markets that have to interact that are yet to be established. So I think our first priority, if you like, needs to be developing domestic markets, understand their constraints, and then from that you can start to build a business case around the interaction of those markets through carriers.
And I think that makes sense within Europe, but I think in other countries where they've got, so for instance, Chile see themselves as a ammonia producer. They maybe don't have, they can produce a lot more than they can use hydrogen. And they've got, wind and they've got solar. So they want to export it. And Australia wants to export. So I think that there's a mixture, but I think you're absolutely right. The fact that you use an awful lot of energy transporting these around, maybe, and with safety implications, then I think the European models are better at the moment. But aren't we lucky?
And I think that these producers, including Scheele, they might take a further step in the value chain. Then, so it might be fertilizers that they are exporting instead of ammonia. Why shouldn't they, so to speak, right? And we see a lot of countries across the African continent that are importing things that they could produce themselves in a green way if they utilize the solar and the wind they have also. So I think we will see it going further down the value chains at many places, and then maybe more of them. But let's see, it's a dynamic world, and I totally agree that we shouldn't make too long scenarios here, actually. There are many things that can happen, of course.
So, yes. We start here, please, Derek. And again, please introduce yourself.
Hi, my name is Patrick Coles from Yokogawa. Thank you for all the great input. One question I have is about building a hydrogen economy. We're also building new infrastructure, which is the equipment supply chain. I mean, if you look at the European plans, they say 20 gigawatts of installed capacity in electrolyzers in 2030, 2035, I think. And at the moment in the Netherlands, we have 1 megawatt running, and the suppliers of the electrolyzers are still making them more or less by hand. So the question is, with all the ambitious plans that we have, how do you look at the supply chain risk? And maybe associated with that, it's very easy now to run to China and say, hey, they're developing a lot of electrolyzers. But maybe this is also an opportunity to build a manufacturing chain again in Europe, and to add to the resilience of our whole end system by also looking at the technology supply. How do you look at that?
I'm happy to start. I mean, if you look at hydrogen production today in the world, it's just a tiny little fraction that is coming from electrolyzers. So the first thing we can do, and as we already spoke about, is to see how do we address that 98% or whatever it is to make that green. Then when we look at electrolyzers, we have basically three types today. So we have the alkaline electrolyzers that have been around quite a long time, and they're okay, so to speak, and there we have hundreds of megawatt scale established. We have PEMs, we built the biggest one so far, 24 megawatt, but there is more in the making. We have 800 or megawatt or whatever on the drawing boards. So these are basically based on modules. So I don't think it is that big a problem scaling it up from that perspective. And then we have the solid oxide that is cooking. Then we are at more of a 1 megawatt scale there. So I'm not too worried about the scale up of the electrolyzers actually, and we have the other supplies of hydrogen that we need to make them green instead, or blue at least. Then, right? But I think that we will be able to scale that up. Then is a very interesting question: where is this going to take place? I mean, we see a rapid development in China. And we might be in a situation as we are with a lot of wind and solar technology that all right, the Chinese are doing it better and cheaper, we buy it from them, and we create a dependency if we are not taking care of it here. So I think that's an absolute valid point to consider. But I'm not worried from a technology point of view. I think the scale up will be there.
So I've got a slightly different point of view. So some of the feasibility studies that we've been asked to carry out recently have been for gigawatts or hundreds of megawatts of electrolyzer, and at that point, those companies have to help the electrolyzer companies to scale up, in my opinion, because otherwise, how are the larger companies okay? They maybe can afford to produce more per year than they are. You know, the capabilities might be 100 megawatts at the moment, and they need to produce 500 megawatts in the near future. So you have to help those companies. It's a sort of a collaborative approach to allow them to produce these electrolyzers, I think, anyway.
I think there are sort of two perspectives I take on this. One, the standard model of supply chain risk management through diversification, so not having all your eggs in one technology basket, which comes back to my earlier point of not trying to pick winners and having agnostic frameworks that allow multiple technologies to compete. So that's kind of step one, is making sure that you're as technology agnostic as possible from a sort of policy perspective to give the greatest diversification. And the second point is around where does the value lie in the hydrogen supply chain. So you've got a number of different actors that all concatenate together that ultimately deliver hydrogen to a customer. And where is the principal value created, and where is it rewarded through the business models and through the various risk allocations through commercial agreements. And it's making sure that the funding that is put into the hydrogen economy can flow down to these suppliers, so they aren't operating on threadbare margins, which will only disincentivize investors, who ultimately are the people and the institutions who will be putting their capital at risk to build up the capacity in these supply chains. There has to be sufficient incentive for them to do so. Otherwise, all the money will go to the other end of the value chain and then put at risk the sort of the ability to deliver.
Have a question at the back again, and then I think...
Yeah, John Gibbons, Sheffield and UK CCSRC. So the point about shipping steel instead of shipping hydrogen was very interesting. And I mean, obviously we used to do that with aluminium, shipping electricity in the good old days, before we made coal-based aluminium. So I got a question really, putting those things together. And bearing in mind that we were supposed to be net zero by 2050, and we've got a lot of particularly steel-making assets around that are relatively new, maybe not so much in Europe, but certainly globally. While we might move to hydrogen eventually, do you think we're going to actually just capture the CO2 from conventional steel plants and ship that steel around as low-carbon steel, and maybe some other applications as well? In other words, are we going to keep going with what we've got, the fuels that we've got, and then more gradually shift into hydrogen? Or do you think somehow or other we're going to build up hydrogen quickly enough to hit 2050 targets with all the investment in, particularly in steel, where you've got to change over from conventional steel making to DRI? I think that's a huge investment just beyond getting to net zero.
I think we will see a combination. And we should be aware of that. If you look at the investments to make DRI, we have the assets we have, and we're going to replace them, then we have a specific investment cost of around, say, $1,000 per annual ton. But if we have to take into consideration the upstream electricity grid and all that, then we are at $4,000 or $5,000 per ton. It's massive investment. So can we use the current assets for a transition. I definitely think so. I see, as I mentioned earlier, I see CCS and CCU, not at least a number of places, coming more into the discussion recently. And we might shut down certain parts of the upstream and import slabs or billets or whatever, but also keep some of the production. So I think it's a combination. Looking at the UK has an export of steel scrap to Turkey that is roughly the same as the import of finished steel products from Turkey. So it's, well, this is the mechanisms that we have, but here in the UK, if we would melt that scrap that has zero carbon footprint in the UK, that could be a good way forward as well, but then you need to make restrictions. So I think there will be a combination of these things, but I don't think that we will see an overnight change of the steel industry in this case. If you look at the companies that we are working with, they have a couple of blast furnaces. They plan to shut down one blast furnace in 5 years' time and replace that with electric arc furnace, some scrap, start building up some DRI, importing something, later on going to using hydrogen in that one, and then in another 5 to 10 years shut down another furnace. It's a phasing out and phasing in.
So no actual capture, they're just shutting down conventional steel.
Well, if you look at the capturing part, that also can play well there. So if you do carbon capture around the blast furnace and then you run the DRI using natural gas for the reduction, you will have a way lower carbon footprint, but still you will have CO2 coming out of that. So if you have a system with CO2 established for the blast furnace, that can also be used for the DRI production when you use natural gas in the transition phase, and then you can start using hydrogen. So I think we will see it more in that type of development, and we can also import products, semi-finished products, etc. Yes.
There was some. Yes, please.
Hello. Hi. Yeah. Sorry, Luke Tan with Supercritical. Thanks for all your input today. So, question is a bit more of an opinion piece. There's been quite a lot of statements around how things can't be deployed fast enough, consents, and really there's a baseline requirement for green electrons to enable all of the sustainable aviation fuels, hydrogen, etc. What do you... We set ourselves a target as well of 2050, net zero by 2050. At what point do we start not having the not in my backyard conversation and starting to take more of a, where it's been demonstrated quite well, where you just sort of force the hand, is in China. I think, Joachim, you mentioned that grey first, green first in China. There are benefits to achieving long-term goals if you force your hand. I'm not saying I'm a supporter of that, but I'd love to hear your opinion on when the time is right to start having that conversation.
I would have thought probably not now. The sort of nature of Western democracies is that things are done by consent, and it's a very quick way to not be elected as a prime minister, to be forcing things on people that they don't want. Although it is undeniable that the driving force of decarbonisation, which is ultimately a societal change, needs to be driven by the free will of the society that is benefiting, and so therefore there is an onus on education. There is an onus on giving genuine choice, and on raising awareness to then allow society to make free choices. So if I give you 3 technology options and then they all ultimately produce the same sustainable outcome, then you can leave it to consumer choice to make that decision. I don't need to force anyone to make a particular decision because it shouldn't make a difference to the policymaker. Now, there will be an inevitable residual gap that has to be closed towards the end of the journey for those who haven't been able to get on board, as let's say that the natural gas grid, for example, converts to hydrogen. If that occurs, at some point the natural gas will be turned off. So for anyone who who hasn't already converted by that point, they will be, there will be a pull factor there. But I don't think we're at the stage of setting out that kind of mandated framework at the moment. I think we should try to do things by consent as much as possible, so I've already covered that. But I don't know if you guys have anything to add.
Only they're kind of a bit off topic, but I think having the energy crisis of late, I think has shown everybody that we can reduce our energy consumption somewhat. The heating coming down. So I think it's probably highlighted the fact that we're using a lot of energy in our houses, and so that may help us sway public opinion in the future. I think that was it. That was all I was going to say.
I will give the populistic answer. When it's cheaper. The problem is that it's more expensive.
Yeah.
When it's cheaper, it's much easier to change. And then coming back to something previously, when we can probably develop something around these local ownerships of it, and we see the job creation. Job creation is also part of getting it cheaper, so to speak, from a personal perspective. You see personal benefits from it. Do we see personal benefits today? No, not very much, to be honest. It's more of that we say, oh, this is good for the world, but do I honestly see personal benefits from it? Maybe not, or a limited at least. But if you feel good about it really, and it works and it's cheaper, you have a better life. But so far, I think many people I talk to, they feel that they're more pushed into this. This is top-down driven for many people. So they want to change these things. There is an agenda, and I got to pay. Right? This is not an easy way to get the general momentum for this in our type of countries, at least, as we were into Thomas there. Right? So we need to make sure that it is not a more costly alternative, or a small premium we can probably pay.
But younger engineers want to work on energy transition projects. They don't want to come to an oil and gas company. I'm sure all of the energy providers will be expecting that. So there has been a bit of a change with maybe the younger generation.
Maybe.
The younger ones, by the way.
Yes. No, for sure. But I think I feel a lot of resistance also at many places, to be honest.
Thank you. The timeline is something that we haven't discussed in it, but it does start when you start bringing in the affordability question. And going back to a point that was made earlier on, electrification is quite important, and if we need to move to renewable electrons for green hydrogen. There is the certification difficulties around that. So how do you see the timeline developing? Maybe Samantha first on this one.
So I think we have to do a vast array of things. I don't think we can focus on one particular thing. So I think many of us are working on a vast array of different spectres in terms of for engineering companies to looking at decarbonisation. I don't think there's one solution. I think we have to do baby steps, and HyNet is a fantastic, very big. Well, I wouldn't call it a baby step. It's a leap, but to allow us to then move on to the next stage, we need to improve our electrical infrastructure. If we want to do significant green hydrogen production, I think Progressive and ourselves are also involved in a Bacton Energy Hub, and in the short term they're thinking about blue hydrogen. In the longer term they're looking at green hydrogen. But I think we all need to start with start with thinking about blue hydrogen, forget about the fact that okay, it's not seen as attractive to some of the American universities, but we need to then, how can we do more and more green hydrogen? And I think we need to do all of that to get to the 2050 goals.
I think I would. It's quite a broad question, given that the technology summit. I'll try and take a technical sort of spin to the answer. So. Ultimately, we've got a patchwork of risks that need to be managed in terms of commercial, financial, regulatory, technical. You have different stakeholders in each of those buckets, and ultimately different people, different boards, different committees. They all are unlikely to talk to each other. They're all going to be making independent decisions, and collectively that aggregate decision making and risk appetite is what will determine the solution. So everyone naturally reduces risk within their own boundary, and that's perfectly legitimate. So what it means is that the solution will inevitably be the lowest risk steps based on the available technology that is at hand. And if you look across the other pieces of the patchwork in terms of commercial, financial, regulatory, all of these are new systems. We have new regulations that are evolving all the time. We've still got the NG bill that hasn't even become law yet. We have business models that are evolving all the time. You have non-standard contract forms, so you don't have hydrogen SPA, for example. There isn't a standard form, etc., etc. So for all of these stakeholders, this is a new environment to come into. And therefore, it means from a technology perspective, the technology has to be as low risk as possible. So if you look at how we use hydrogen today in very round numbers, in the UK, we use around 1 megaton of hydrogen currently. That is produced through reformation, that is used in industrial processes. And so that therefore it is no surprise that the first steps of the low carbon economy effectively take that model and bolt on CCS. Now you have, of course, green hydrogen projects coming up, but the majority of the initial phase is blue, and that's understandable when you look across the aggregate risk profile that needs to be adopted. Now, as those other risks come down, so as the regulatory framework becomes more known and more familiar, as the business models become more standardised, then more technical risk can start to be absorbed with slightly more nascent technologies like maybe pyrolysis or in industrial fuel cells. But you can't just look at technology by itself. It has to be looked at in the context of the overall risk profile of moving the economy forward. You have to bring down the other risks, and then you can start to introduce a bit more technical risk, as opposed to getting very sort of myopically focused on one technology as the solution, and then everything else has to work around that answer.
When I touch upon hydrogen, working with hydrogen, actually not many people have worked with hydrogen. Sure, observe a lot of people talk about hydrogen, not very many have worked. There was only hydrogen, right? And then suddenly started to be a lot of colors and stuff like that, right? And which was quite confusing for us, I must say. And the spectrum of colors are enormous today, and I think it's an opacity here. We need to have certification of the emission footprints, not only the carbon footprint. And I think that we will grow up and move away from green and blue and pink and yellow or whatever, and having third-party certifications of it. And that will be quite interesting also, because if we take in scope 3 into that, I'm not so sure that people will be so happy to buy hydrogen that is produced from offshore wind farms, for example. So and then we will have fact-based transparency, and we can probably draw some lines and say that this is ultra low carbon hydrogen, this is low, and so on. But we need to have third-party certifications, and I don't think it's too far away to get there. But I'm not always sure that all players are so keen to push it in that direction. But definitely, we need to, and that would support developments of different policy frameworks as well, of course.
Are there any more questions from? Yes, please.
Hi, Patrick Coles again. I do want to respond to Thomas. I mean, we run the risk of thinking that we have a perfect understanding of risk, saying people work on low risk, but I mean, do we understand the risks of, you know, tipping behind 1.5 degrees? And do we also factor in regrets? I mean, you know, losing a natural habitat might not be a big risk, but it's a huge regret for society if we go that way. So my worry is a little bit, we take a very business context analysis of this all, and we balance our risks in a business and government context, but are we capable of really factoring in the consequences of not moving fast enough?
I think my response would be that those sort of societal risks are principally borne by governments as opposed to any individual business. Individual businesses have a role to play in contributing, and I'm not saying that they are immune from being part of the solution, but those very macro risks, the solution to them doesn't lie in any one individual business, right? It relies in a policy framework that then achieves an outcome and allows private entities to participate in that transition. And it comes down to who is the driver of change. So if governments are very willing to effectively take on all of the ownership of the transition, then you're dealing with effectively a single source because they will be underwriting all of the investment. But the reality is that government will be the sort of kickstarter, if you like, of these new economies through subsidy regimes, etc., and they will transition relatively rapidly towards a market-driven solution, and therefore you have to have a market perspective if you want the outcome to be achieved. I have sympathy for the cause, but I think those macro considerations have to flow through policy and then through to business models, as opposed to ignoring the policy.
Thank you. I see one more question there, and I think we better make that the last question for this session.
Thanks. Will France from Government Department for Energy Security and Net Zero. So there's a really interesting conversation before about hydrogen carriers, but I was interested to kind of hear thoughts from the panel on the role of the national gas grid in terms of kind of more of a national level kind of hydrogen distribution and transport challenge.
So recently I've heard that the plan is no longer to have 100% hydrogen in the national gas grid. I don't know if that was a rumour, but to see it as somewhere to put the hydrogen to start with is a really good idea, because one of the concerns at the moment is that you've got all these producers that want to produce hydrogen, but they've got nowhere to put it. Particularly as we don't particularly want to transport hydrogen around. So I think putting 20% up to 20% of hydrogen in the national gas grid is a fantastic idea, and it might only be short term, but I think yes, good.
You can put hydrogen into the gas grid.
Not by law.
No, but I mean, principally you can use it for transportation. You can put in the hydrogen molecule here and take it out there. There are technologies for that to use it for transferring. To put hydrogen into a natural gas blend is, from a decarbonisation point of view, not yielding very much. If you put in 20%, it means 7%, right? Again, the energy content. So probably using that hydrogen directly into a process is much more effective way, efficient way when it comes to decarbonisation. But you can definitely use it as a means of transportation, if it's allowed.
Just to add to that, I think I take a slightly different view, but it's
it's good.
That a megawatt hour of hydrogen that displaces the same higher carbon fuel, let's assume it's natural gas,
yes,
produces the same decarbonisation benefit independent of the use case. So the network is merely the means of transportation as opposed to a sort of independent indicator of the reduction in emissions. On the point of Blending, it's the case for blending is relatively strong to effectively disconnect supply and demand initially, so that you can allow a supply side to build up. So in the UK, that's roughly 5 gigawatts of capacity, without relying upon conversion of demand side technologies. So you sort of decouple supply and demand, which is beneficial from a strategic perspective initially. In terms of the longer term prospects of full conversion, they are still unanswered questions. There is a question around safety and asset integrity integrity of the network itself, which is a principal consideration, and then of course the downstream considerations within the home. But it's one of the key questions which will determine the ultimate role that hydrogen will play within the economy, because it effectively unlocks domestic demand in a 2050 scenario. So yeah, it is a principal question, but it's yet to be answered, but hopefully will be in the next few years.